Hello, good afternoon everybody. I am going to take this support vector machine, okay, which is one of the main important algorithm in machine learning. We are going to see in detail, okay. Still now we have seen the linear regression, logistic regression, types of logistic regression, and decision tree algorithm, right? Which is also very important in support vector machine learning algorithm is very important in AIML, okay. Or let us see in detail, okay. So what do you mean by support vector machine algorithm? Support vector machine, or it should be short form as, it can be called as SVM, is a supervised learning algorithm that can also be used for classification and regression problems. However, it is primarily used for classification problems. The goal of SVM is to create a hyperplane or decision boundary that can segregate data sets into different classes. The data points that help to define the hyperplane are known as support vectors. Hence, it is named as support vector machine algorithm. Okay. So let us see what is the basic concept behind the support vector machine algorithm. Okay. A support vector machine aims to find the hyperplane that best separate data points of different classes in a high dimensional space. That is what here. It can separate the data points as a hyperplane, maximum margin and positive hyperplane and negative hyperplane. So below it is negative hyperplane and after it is a positive hyperplane. In between it is what? Maximum margin hyperplane or support vector. Maximum margin is nothing but we can get the maximum width of the hyperplane. That is what this is. And this above, that is the orange lines, and this green color shows that support vectors. These are nothing but the support vectors. And here it is a maximum margin, and here it is a maximum margin hyperplane. And if it is above the threshold, it is a positive hyperplane. If it is below the threshold, it is a negative hyperplane. Okay. Let us see how it works. Okay, this is what the mathematical formulation behind the hyperplane. In the n-dimensional space, the hyperplane is a flat affine subspace of dimension n-1. For the two cases, it can be defined as y of x plus b is equal to 0, where w is the weight vector perpendicular to the hyperplane and b is the bias term. The margin is the distance between the hyperplane and the nearest data points from either class. SVM is to maximize this margin. Okay. Next, third one is what? Kernel ring. For non-linearly separable data, SVM, that is support vector machine algorithm, uses the kernel trick to transform the data into higher dimensional space where the linear separation is possible. This common kernels includes linear kernel and polynomial kernel. No transformation suitable for linear separable data and transform the data into polynomial features, allowing for curved decision boundaries. Okay, there are two types of kernel. Number one is what? Linear kernel. Number two is what? Polynomial kernel. Before that, we had to see what is a kernel. It transforms the data into high dimensional data space where the linear separation is possible. No transformation suitable for linear separable data and transform the data into polynomial features, allowing for curved decision boundaries. Okay. Next one is what? Radial basics function kernel maps the data into infinite dimensional space using Gaussian function, which is used for capturing complex relationships, and sigmoidal based on sigmoid function resembling a neural network's activation function. This is what the three main basic steps behind the support vector machine algorithm. Okay, number one is what? Basic concept, that hyperplane, positive hyperplane, negative hyperplane, intermediate hyperplane, and this maximizes the margin between the classes and the distance between the hyperplane. And number two is what? Mathematical formulation. and number 3 is what? Kernel trick. Let us see some more steps in the next upcoming PPT. Thank you all.